Welcome to The Explainer. I am so glad you're here. We are about to take a really focused, deep dive into the actual mechanical heart of our global infrastructure. When you look around your room, you see lights, computers, all these appliances, and they're all just humming with this silent, invisible power. But where does it actually come from? Today, we're essentially stripping away the drywall and the power lines to look directly at the beating heart of the modern electrical grid. So let's jump right in. It sounds kind of primitive when you say it out loud, doesn't it? How does a basic spinning wheel manage to power the entire modern world? And yet, almost every single watt of electricity powering your life right this very second is generated by mechanical motion. We're talking about massive turbines spinning at just incredible speeds. The story of the electric generator is really the story of how we capture that physical, kinetic motion and transform it into flowing electrons to make an electric current. It's this beautiful energy conversion that relies on literally some of the most elegant classical electromagnetism in the universe. So here's our blueprint for the explainer today. First, we'll look at the magic of motion. Second, Faraday's law of induction. Third, we'll go inside the electric generator. Fourth, magnetic flux and EMF. And 5, generating the AC waveform. All right, let's kick things off with section 1, the magic of motion, mechanical to electrical. Think of an electric generator as the ultimate energy translator. Because you know the rule of conservation of energy, right? We can't just create energy out of thin air, we can only change its form. So whether it's the kinetic energy of water rushing through a massive hydroelectric dam, wind turning a giant windmill, or highly pressurized steam from a nuclear reactor turning a turbine, it all boils down to mechanical energy. And here's a super fascinating little fact. A generator is essentially the exact reverse of an electric motor. While a motor takes electrical energy and turns it into mechanical rotation, our generator takes that mechanical rotation and uses electromagnetic induction to pump out electricity.
Moving right along to section 2, Faraday's law of induction, the invisible trigger.
Discovered independently by Michael Faraday and Joseph Henry, the rule is this: a changing magnetic field produces an electric current. This breakthrough in classical physics is absolutely the bedrock of our modern world. But I want you to notice the emphasis on the word changing there. If you were to just place a copper wire next to a giant, perfectly still magnet, absolutely nothing happens. A steady magnetic field doesn't do anything for us here. But the moment you move that magnet, the second you introduce motion and change the field relative to the wire, the electrons in that wire are suddenly compelled to move. So the key takeaway is that motion is the invisible trigger bringing those magnetic forces to life.
To really wrap our heads around this, we need to picture what Faraday was actually measuring: magnetic flux. Just imagine a magnet emitting these invisible lines of force, kind of like a highly concentrated laser grid. Magnetic flux is basically the total number of those invisible field lines passing through a specific surface, like the empty space inside a loop of wire. If the loop is perfectly perpendicular to the magnet, it catches the maximum number of lines, right? Maximum flux. But if you tilt the loop so it's parallel to the lines, they just slip right past, and the flux drops to 0. That constantly changing angle? That is going to be our secret weapon.
Okay, let's get into section 3, inside the electric generator, anatomy of a machine.
Let's essentially crack one of these open. An alternating current, or AC generator, relies on 4 main physical parts. First up, you have the stator. These are the fixed north and south magnetic poles that provide that constant, imposing magnetic field. Suspended right between them is the armature, which is this tightly wound, spinning copper coil wrapped around a metal core. Now, as this armature spins, we obviously need a way to extract the electricity without instantly tangling all the wires up. That's where the last 2 pieces come in. We use slip rings, which rotate right along with the armature, and brushes. These brushes are usually carbon rods that stay completely stationary, just constantly pressing against the spinning slip rings to cleanly transfer that electric current out to the grid.
Now, there's a really subtle mechanical trick here that completely changes the type of electricity you get. An AC generator uses those unbroken slip rings we just mentioned. Because the coil is spinning, the side of the wire closest to the North Pole is constantly swapping places with the side closest to the South Pole. That naturally creates a current that alternates its direction. But if you want direct current, or DC, where the power flows strictly in one direction, you'd replace the slip rings with a split-ring commutator. It's this clever little device that physically reverses the connection to the outside circuit every half turn, forcing the electrons to only march forward.
Which brings us to section 4, magnetic flux and EMF, the chain reaction.
Let's walk through this elegant cause and effect chain step by step. Step 1, the external mechanical force, like a massive steam turbine, kicks in and violently spins our copper armature. Step 2, because it's spinning inside a fixed magnetic field between the north and south poles, the angle of the copper coil is continuously changing from perpendicular to parallel, over and over again. Step 3, this changing angle means the magnetic flux piercing through the coil is constantly varying from maximum to zero back to maximum. This rapid variation induces an electromotive force, or EMF. And finally, step 4, that EMF acts as the pressure. It's like an invisible hand pushing the electrons through the copper wire, creating the flowing current that leaves the generator. It's honestly brilliant.
And there's a super important mathematical relationship governing this whole chain reaction. The faster the magnetic field changes, the greater the induced EMF. It's a direct proportion. So if a power plant needs to push out more voltage to meet peak demand on a really hot summer day, they need more mechanical energy. By ramping up the speed of that spinning turbine, the rate of change of the magnetic flux sharply increases, and the resulting electrical output scales up right along with it.
Finally, Section 5. Generating the AC waveform, the final payoff.
When we map this out, it perfectly illustrates what alternating current actually looks like over time. If you put time on the horizontal axis and voltage and current on the vertical, you get a perfect sine wave. Starting at 0, the voltage smoothly rises to a peak as the rotating coil hits that optimal angle of magnetic flux, and then it drops back to 0. But as the spinning coil continues its rotation and flips its orientation entirety in the magnetic field, the polarity entirely reverses. The current dips down into the negative, representing electrons flowing backward, before returning to 0 to complete one full mechanical rotation.
To put that into perspective, if you're in North America, the electricity coming out of your wall socket right now is rated at 60 Hertz. That means that elegant sine wave we just walked through, that full mechanical rotation of the massive copper coil inside the generator, is happening 60 times every single second. It's wild. It translates abstract electromagnetism into something you can literally see. When you flip a switch, those flowing electrons are vibrating back and forth incredibly fast, transferring energy to heat up a filament or excite a gas and successfully lighting up the dark in your room.
So as we wrap up this explainer, I really want to leave you with this thought. We just looked at a single spinning coil, but to power entire cities, countries, continents, just think about the sheer, staggering scale of the magnetic forces at play globally right this very second. Deep inside the concrete walls of hydroelectric dams and massive thermal plants, house-sized metal armatures are endlessly spinning between gigantic magnets, tirelessly converting the motion of the Earth into the spark of the modern world. It is a true engineering marvel. Thank you so much for joining me for this explainer. I hope you leave with a newly sparked curiosity about the hidden engines powering your world.